See, first we will derive the equation of a line. If x1, y1 is a point on the line which makes an angle theta with the positive direction of x-axis. We're going to derive it as x minus x1 by cos theta equal to y minus y1 by sin theta equal to r, where r is the distance between any general point p of xy and the fixed point q of x1, y1. Theta is the angle which the line PQ makes with the positive direction of x-axis. So, from the diagram we see that if theta is the angle made by this line with the x-axis, then if I consider QR to be a line parallel to this OX, then we have theta to be the angle made by this line with the QR also. So, from this right angle triangle, we can easily see that this distance, when we consider this distance, call it as RQ. When we consider this distance as RQ, then from the diagram we can see that this RQ is nothing but R cos theta. From the diagram we can see that it is R cos theta, and if we consider this distance, that is PR, then it is PR is nothing but R sin theta. Now we would like to calculate this in terms of this x and x1, similarly y1. So what we do is we just see this distance. This distance we have it as x because this is the point P of xy. So if we have got this as x and this one being x1, so if you want to know what is nm, then it is x minus x1. Then it is x minus x1. So this length being same as this, we conclude that our x minus x1 is equal to r cos theta. And the same way we have y minus y1, because the entire length is y, and we have only this one to be y1, and therefore this is y1. So y minus y1. So that I will get this PR. So we have y minus y1 is equal to r sin theta. So using this x minus x1 by cos theta is equal to r, y minus y1 by sin theta is equal to r. So these two together gives us this equation, which is the equation of this line which makes an angle theta which passes through the point x1, y1. Now we want to find the equation of pair of tangents from x1, y1 to the parabola y square is equal to 4x, and we are going to show that it is t square is equal to ss1. So for which we consider this line and q to be q of xy to be any point on it, and p of x1, y1 to be a point from which we are going to show that two tangents we can draw, right? So you have p of x1, y1, and we will take this line equation from the previous discussion, x minus x1 by cos theta equal to y minus y1 by sin theta equal to r. Right, now from this we can get x as this and y as this. Now this point will lie on, see, we want to have this to be a tangent to this, so it has to lie on the parabola. Therefore we have to replace our y and x by these two quantities. So we have this. On simplification we can get this as a quadratic equation in R, and in that case we will have that, see, this one will meet in 2 points, but we want it to be tangent, so we'll have to have the roots to coincide. So this one, if we have it as say the roots r1 and r2 means we want them to coincide. So for the roots to be equal, we know that the discriminant is 0. That is, if we write it as ax square for any equation which is of the form quadratic equation, ax square plus bx plus c equal to 0, then for this equation to have equal roots, then we know that b square minus 4ac, b square minus 4ac is 0. So we compare this and we see that what is b and what is a and c and substitute. So here 2 you have, and this 4a you have. So you have 4 and another 4 here. They will get cancelled, giving you only this. But in our discussion, we don't want our theta over here. So we'll have to replace our theta from this equation 1. Replace sin theta by y minus y1 by r, and replace cos theta by x minus x1 by r. So when you do so, you get like this. So in this you will have r square, so that will get cancelled, and patiently if we simplify this, then we will arrive at this to be of the form yy1 minus 2ax minus 2ax1 the whole square is equal to y square minus 4ax into y1 square minus 4ax1. So taking this one as s and this one as s1 and this as t, this is the usual notation, we conclude that the equation of pair of tangents is given by t square is equal to ss1. That is the equation of pair of tangents drawn from the point x1, y1. So these are the main steps in deriving this. First you write down the equation of the line, and then solve that with y square is equal to 4ax. Then you will get a quadratic equation. So you will have to have that discriminant must be 0, and we are using that. This is our discriminant. So we are using that, and then we'll have to eliminate theta. So if you remember these steps, then the the entire proof can be easily derived. The steps can be easily arrived at. Now next is the problem 1. Show that the locus of points of intersection of tangents of y square is equal to 4x which intercept a constant length d on the directrix is something. So we first understand what is given. We want to find the locus of point of intersection. So you take the point of intersection as x1, y1, whose locus only we are going to find. And once locus is to be found, we need to have some conditions. So here the given condition is we have this one makes intercept constant length d. So that means, so this is the directrix, and this is the intercept this one makes. So once we have this point and this point, using the distance formula, equating that to d, and dropping the suffix by eliminating the unknown quantities and then dropping the suffix, we will get the locus. So you consider p of x1, y1, and so the equation becomes t square is equal to ss1, and you'll have to solve that with the directrix. So when you do so, then you will arrive at this. You can see that it's a quadratic equation in y, and so it has got two roots. We shall name them as y1 and y2. So sum of the roots and product of the roots, this is and the product of the roots, both you get. So we want to know only d square, so which is y1 minus y2. See, it's a point on the directrix, so the coordinates will be minus a comma y1, and the other one to be minus a comma y2. So your x coordinate will remain the same. So when you find the distance, naturally the difference between these two, the square of it, will only be our d square. So this is what we have. Already we have got y1 plus y2, y1, y2. So rewrite your y1 minus y2 the whole square in terms of these two. So this is what we have. So and then cross multiplying, simplifying, dropping the suffix, you get the locus. Right? So do not write dropping the suffix in the examination. You are supposed to write just the locus of this is equal to this. So what have we done in this? We have the equation of pair of tangents given by t square is equal to ss1. This is known to us. And then we'll have to solve that with this. Why we need to solve? Because it is making intercept with the directrix. So you'll have to consider that and you'll have to solve these two. So from which you'll get a quadratic equation in y, quadratic equation in y. So from which you will get the sum of the roots and product of the roots. So using which you can determine this. Then perpendicular tangents to a parabola intersect on the directrix. So perpendicular tangents. So you need to have pair of tangents. So when they are perpendicular, they will have to intersect only on the directrix. That's what we are trying to do. So you have equation of pair of tangents being given by this t square is equal to ss1. Expanding this, so for two lines to be perpendicular in the first chapter itself, that is in the preliminaries, we have given that the condition for the combined equation to represent the perpendicular lines is that coefficient of x square plus coefficient of y square equal to 0. So you rewrite this equation in such a way that you get coefficient of x square and coefficient of y square, and of course with that along with that you will have some more terms. We are not bothered about them, so we need to know only what is coefficient of x square and what is coefficient of y square. You can take either bring this to the left side and simplify, or take this to the right side and simplify. Then on simplification, this is what you get. We need only the locus, so we have this. So the main points, you will have to have t square is equal to ss1, and then you are using coefficient of x square plus coefficient of y square equal to 0, and then you are determining the locus. So here if two tangents are drawn to a parabola making complementary angles with the axis of the parabola, prove that the chord of contact, so we have chord of contact passes through the point where the axis cuts the directrix. Axis cuts the directrix. So at that point you have the chord of contact passing through that point. So that is what we are asked to establish. So the diagram will somewhat look like this. You have parabola, and from this point T of x1, y1, when we consider two tangents, this will be your chord of contact, and this is your directrix. So this is your directrix, and this directrix and that chord of contact, we have to show that the point of intersection is this one, which is a point on the axis as well as on the directrix. So this point is exactly minus a comma 0. So we have to establish that the chord of contact passes through this one. So how do we do that? So we first make use of this. Here pair of tangents t square is equal to ss1. Even with that we can do the problem, but this will be somewhat simpler than that. So what we do is, because here these two make complementary angles that's given to us, so we will make use of this concept. So we have y is equal to mx plus a by m. This is the condition for y is equal to mx plus c to the tangent to parabola. So we directly replace our c by a by m. So this will be definitely tangent, and this x1 y1 is a point lying on that. So because x1 y1 lies on that, you will have the equation to be y1 is equal to mx1 plus a by m, and this on simplification will give you this, and this being quadratic in m, it will have two roots. So you can name them as m1 and m2. m1 stands for tan theta 1, m2 stands for tan theta 2. Now because we are given two angles to be complementary in the statement, we are given that these two make complementary angles, so the sum should be 90 degrees. For complementary you need to have the sum to be 90. For supplementary it is 180. So tan of theta 1 plus theta 2, by the formula you have this, and because theta 1 plus theta 2 is 90 degrees, this becomes infinity, so you have this. So naturally you have to have the numerator is non-zero, that we have to ensure. So sum of the roots from here m1 plus m2 is equal to y1 by x1. So that is finite quantity, and therefore this is non-zero quantity, and this one should be 0. So 1 minus m1 m2 is equal to 0, or in other words m1 m2 is equal to 1. So that is because what he has given, from that we have got. So m1 m2 is equal to 1, and already from here product of the roots is a by x1, so a by x1 is equal to 1. So that in turn implies that x1 is equal to a. So the equation of the part of contact of tangents from so the point now becomes, see, first we had this to be x1 y1, now that we have a y1. So having got this, see, we are yet to get the equation of the chord of contact, right? So having got this one from the given condition, now we can write out what is the equation of the chord of contact. See, we know that from x1 y1 it is y by 1 is equal to 2a into x plus x1. But here you have your x1 to be a. So that means your equation will now reduce to 2a equal to 2a into x plus x1. Instead of that you have a. So this is what you have, y by 1 is equal to, so this will be the equation of this chord of contact. Now this has, when it meets y is equal to 0, when it meets y is equal to 0, so what will be your x value? So that gives my x value to be minus a. So when it meets the y-axis, then that point should lie on the direct x and x. So you have the problem, the chord of contact meets the x-axis, y is equal to 0, and therefore x plus a is equal to 0. So that point is minus a comma 0.